Hello students. Now I'm here with you with the new chapter and with a new topic. Okay, and you're welcome in online maths class. Again, I'm telling you, keep NCERT book and a notebook with you. By that, you can better understand the topic. Okay, so today's chapter is there, Introduction to Trigonometry. Okay, and it is a new chapter for you, and topic is there. We need to learn in the first videos, introduction of trigonometry, okay, and trigonometry ratios. Two things we are going to learn in this topic. Okay, so you can see there are the many things. Trigonometry is the triangles, and mostly it will be based whatever you are going to learn, so that is based on right angle triangle. And the part of right angle triangle you know very well. Right angle triangle means whose one angle is 90 degree, and it is having a hypotenuse, triangle, sides, many things are, many terms are there. So all the terms I am showing to you, whatever the terms we are going to use in this chapter. Okay, so first see the introductory activity for you. Let's take some examples from our surroundings where right angle can be imagined to form. Okay, so see here, if a student is looking at the top of the tower, you know it is just a vertical top of the tower, a right triangle can be imagined to be made. See here, one tower is made in front of you. You can see the one tower is there, and any student at the top of the tower, and he is trying to look to the bottom, so you can see this figure will be formed or not, which is in front of you, and you know very well it is a right angle triangle. Okay, now let's another example. Half slice of bread can be imagined to be made a right triangle. Okay, it is imagined or not? Yes, half slice of bread can be imagined to be made a right triangle. See there, take a piece of bread and half slide it from the diagonal, then you can see it is a form of right angle triangle. Okay, now in all the situations, distances or heights can be found by using some mathematical techniques. You know about the Pythagoras theorem very well. Then there two sides are given, so by the using Pythagoras theorem we can find out the third sides, so which comes under branch of mathematics called trigonometry. Again I am repeating, in all the situations, distances or heights can be found by using some mathematical techniques which comes under a branch of mathematics called trigonometry. It means now the question can be raised here, by the Pythagoras theorem we can find out if two sides are given, so easily we can find out third side. But with the help of trigonometry, if only one side is given, if only one side and one angle is given, so we can find out the other two sides. This is the difference of trigonometry. Okay, so trigonometry is derived from Greek word tri plus gon plus metron. Tri means three, gon means side, and metron means measure. So in fact, trigonometry is the study of relation between the sides and angles of a triangle. Okay, now historical background, from where it is started, who started. Okay, so see, the history of trigonometry dates back to the early age of Egypt and Babylon. So it started in Babylon. Angles were then measured in degree. You know, one unit of angles is degree also. It was then advanced by the Greek astronomer Hipparchus in the 2nd century of BC, who compiled a trigonometric table that measured the length of chord subtending a various angles in a circle of a fixed radius r. It means it started in Babylon. Okay, whatever the change, who started, that is the astronomer Hipparchus, started in the 2nd century of BC. Okay, Hipparchus is considered the greatest astronomical observer, and by some the greatest astronomer of antiquity. He was the first Greek to develop quantitative and accurate models for the motion of the sun and moon. Okay, this is the image for Hipparchus I have given to you with his solar and lunar theories and his numerical trigonometry, he was probably the first to develop a reliable method to predict solar eclipse. Okay, that was the historical background of trigonometry. Now we are going to learn again, repeating the concept of right triangle. A triangle in which one angle is equal to 90 degree, you know very well, is called a right angle triangle. The side opposite to the right angle triangle is known as hypotenuse. That's I already taught you. Okay, AC is the hypotenuse for a triangle ABC. If B is the right angle, so in that case AC is the hypotenuse. The other two sides are known as legs or base, otherwise you can say perpendicular and base. Here it is written legs or base. Legs and base both are the same thing. And next one is altitude or hypotenuse, altitude or perpendicular. Okay, if B is right angle, in that case AB and AC are base and altitude respectively. Okay, so hypotenuse is always fixed, it will be never changed. Okay, whatever the opposite side of right angle, it will always hypotenuse, but perpendicular, otherwise you can say altitude or base, can be changed to each other. Okay, now see one right angle in front of you, same, you can see B is a right angle here, so opposite side of B, that is AC, so AC is always hypotenuse, it will never change. But it may be possible BC may be, now BC is base, you can consider, and AB is altitude, but it is also possible AB is base and BC is altitude. What are the condition we will learn in this topic. Okay, now Pythagoras theorem. Again we are repeating Pythagoras theorem. In any right angle triangle, the area of the square whose sides is the hypotenuse is equal to the sum of the areas of the square whose sides are the two legs. Two legs means they are the base and altitude. Okay, so in the figure of that triangle just I have shown to you, we can write here hypotenuse square is equal to base square plus perpendicular square. So our altitude is square, so we can write here AC square is equal to AB square plus BC square. Okay, now one Pythagoras example for you. We can see here ACB, here C is the right angle and it is given to us B is equal to 4. Okay, capital B angle, so whatever the opposite side of capital B, that is the side length, is small b. Whatever the opposite angle, whatever the opposite side of angle A, that is the small a side, and whatever the opposite side of angle C, that is the small c side. It means whatever angles we are taking, the opposite side will equal the same measure. Okay, it is we can let it now. So what is given here, A is equal to 3, it means BC is equal to 3, AC is equal to 4, that is B is equal to 4. So we have written here C is we need to find C means AB, so we will use here Pythagoras theorem. We have used the A square plus B square is equal to C square, and we need to put the value of A, that is 3 square plus 4 square, so 3 square 9 plus 4 square 16 9 25, that is C square, and what is C, that is under root 25. So C is equal to 5. So by the help of Pythagoras theorem we can find out the third side if any two sides are given to us. Okay, now why trigonometry? So see, in Pythagoras theorem we have given two sides, just I have already told you in very layer. See, in Pythagoras theorem we have given two sides, and using theorem formula we can find the third side. But in few questions we know the dimensions of one side only, and we find other two sides by using trigonometry. Okay, now trigonometry ratios for you. One triangle is given to you here, angle B is a right angle and theta angle is angle A. Okay, and to I have already told you, whatever the opposite side of right angle, that will be always hypotenuse. Keep in your mind, because many times the students are facing problem in these points. To keep in your mind, opposite side of right angle, opposite side of right angle is always hypotenuse. First point. Second point, this is very important also, the opposite side of theta angle, opposite side of theta angle is always altitude or perpendicular. The opposite side of theta angle is always perpendicular or altitude. So you can see beta, theta angle is here A. So what is the opposite side of angle A? That is BC. So BC is perpendicular here, and remaining side is base. So how we will recognize the side? Again I am repeating, the opposite side of right angle is always hypotenuse. Number 2, opposite side of theta angle is always perpendicular altitude, and remaining side will be base. Okay, so we are going to learn here trigonometric ratios. So these ratios depend on the sides of the right angle triangle. So we have only 3 sides, that is hypotenuse, perpendicular and base. Okay, so first ratio is there, sin theta. What is sin ratio is there? Theta we are using as a variable. So sin theta, and the reciprocal of sin theta is cosec theta. Reciprocal of sin theta is cosec theta. Then second one is cos theta, and reciprocal of cos theta is sec theta. And third one is tan theta, and the reciprocal of tan theta is cot theta. Reciprocal, you know, suppose one example, I have given to you x. So what is the reciprocal of x? That is 1 upon x, or not? Okay, so same thing, sin theta, and reciprocal of sin theta is cosec theta. So what is the reciprocal of sin theta? 1 upon sin theta, or not? So we can also write cosec theta is equal to 1 upon sin theta, but this formula will learn in next video. Okay, so these are not important here. So we are going to learn here what are the trigonometric ratios and how we will find for a particular triangle. Okay, so one formula I have given to you, Pandit Badri Prasad Har Har Bhole. By this you can learn very easily. Here P for perpendicular, keep in your mind, P for perpendicular, B for base, and H for hypotenuse. Okay, so sin theta is equal to P upon H. Pandit, you will write there sin cos tan. So Pandit Badri Prasad and upon Har Har Bhole. First in numerator you can write Pandit Badri Prasad, it means PBP, and in denominator you can write Har Har Bhole. So what is coming here? Sin theta, to P upon H. P upon H means perpendicular upon hypotenuse. Okay, first formula, keep in your mind, sin theta is equal to P upon H, it means perpendicular upon hypotenuse. Okay, and second thing is there, cos theta. Cos theta means B upon H. B for base, and H upon H means hypotenuse. So B upon base upon hypotenuse. Tan theta is there. Tan theta you can see there, P upon B. P means perpendicular upon base. And now the 3 more ratios are there, cosec theta, sec theta, and cot theta. So cosec theta is the reciprocal of sin theta. So whatever denominator, it will be converted into numerator, and numerator convert into the denominator. So cosec theta is equal to H upon P. It means hypotenuse upon perpendicular. Sec theta means H upon B, hypotenuse upon base, and cot theta means B upon P, means base upon perpendicular. You will learn in easy way, that is Pandit Badri Prasad upon Har Har Bhole. When you are going to find sin theta, cos theta, and tan theta. When you will find out cosec theta, sec theta, cot theta, so they will be changed because these are the reciprocal. Okay. Now trigonometric ratios, just I am giving all the things here, definition, symbols and diagram. You can see here definition, symbols and diagrams. I have given all the things here, you can read it. If any kind of problem you are facing here, so you can ask to me. So just read the definitions here. Students, I am giving you 1 minute, read the definition. Okay, so I hope so you have learned to read the definition. Now one thing you can see here, somewhere sin A and sin B, here right angle is C. So C cannot be the theta angle because C is the right angle. So theta angles may be A or B. So sin A, but whatever the I already told you, sin theta is equal to perpendicular upon hypotenuse, P upon H, Pandit Har, Pandit Badripasha, तो P is coming, Har बोले H is coming, तो P upon H, तो P upon which means perpendicular upon hypotenuse. So sin A is equal to written here. Opposite leg means opposite side of angle A. Opposite leg means here opposite side of angle A, so that is small a, and upon hypotenuse that is small c. Now for sin B, formula is same, perpendicular upon hypotenuse. Formula is same here, okay, but formula is same here, but you can see that is B upon C. Why B upon C coming? Because I already told you, if theta angle, whatever the side opposite of theta angle, that will be perpendicular. So here theta angle is B or not, because sin B is written there, in place of theta B written, theta angle is B, so we can write here opposite side of angle B, that is B, so it is perpendicular, so B upon C. Simply you can write opposite leg upon hypotenuse. Opposite leg means here whatever the opposite side of angle given here. So sin A was given, so opposite side of sin A, that is angle A, that is opposite leg. Got it? Same thing all are given here, sin A sin B, cos A cos B, tan A tan B. Okay, now values for trigonometric function for angle C, that's I already told to you. Sin theta AB upon AC, see there, here right angle is B and we are going to find out the value for the angle C. So sin theta is equal to, because theta is here, C angle, sin theta is equal to AB upon AC, because AB is the perpendicular and AC is the hypotenuse. Same thing cos theta, base upon hypotenuse, so BC upon AC, like that we have all the, and now see, I have told sin cosec theta is the reciprocal of sin theta, so sin theta is equal to AB upon AC and cosec theta is equal to AC upon AB, it means reciprocal of sin. Cos, you can see cos and sec theta, so cos BC upon AC and sec theta is equal to AC upon BC, reciprocal again. Now tan and cot, tan theta is equal to AB upon BC and cot theta is equal to AC upon AB. Okay, now what can you do with trigonometry? What the things we can do by the help of trigonometry? Historically it was developed for astronomy and geography. In the starting it was developed only and only for astronomy and geography, but scientists have been using it for centuries for other purpose too. Other fields of mathematics, trigonometry is used in physics, engineering and chemistry. Within mathematics, trigonometry used primarily in calculus. Calculus you will study in higher classes, from 11th 12th class you will study. It is a branch of mathematics also. Linear algebra and statistics, since these fields are used throughout the natural and social sciences, trigonometry is a very useful subject to know. It is also interesting and very useful to us. Now what are the applications? Measure in accessible lengths. Okay, we can measure in accessible length. Height of buildings we can measure, tree, tower, whatever. Width of river we can measure, and angle of elevation and depression we will discuss in the next video. Okay, so these are the applications. Some application we will also discuss in this chapter. Now conclusion, what the conclusion we get? Trigonometry begins in the right triangles, but it does not have to be restricted to triangles. Okay, the trigonometric functions carry the ideas of triangle trigonometry into a broader world of real valued function and waveforms. Trig functions are the relationship amongst various sides in right triangles. The enormous number of applications of trigonometry include astronomy, geography, optics, electronics, probability theory, statistics, biology, medical imaging, CAT scans and ultrasounds, formation, seismology, land surveying, architect. Okay, these many are fields where we can use trigonometry. Now calculate one example for you. Calculate the trigonometric function for angle theta. Triangle is given to you, where theta angle given and alpha angle given. Okay, and right angle. So three sides are given there. If two sides were given there, so you can find out simply by using Pythagoras theorem. You can find out the third side. So what is the value of sin theta? That is 4 upon 5, because for theta angle perpendicular is 4, but for alpha angle perpendicular is 3, because I have told you whatever the angle is there, we are taking the opposite side is perpendicular. So sin theta is equal to 4 upon 5, but sin alpha is equal to 3 upon 5. Like that, cos theta is equal to 3 upon 5 because base is there, but cos alpha is equal to 4 upon 5. Like that we can find out. So what is the relation between alpha and theta? Very very important thing is there. They are complementary angles, because one angle is 90, and you know very well if the sum of two angles is 90 degree, so those are complementary. And here we can see alpha plus theta is equal to 90 degree, or alpha is equal to 90 minus theta, or alpha is equal to 90 minus theta. Now second example, given here sec theta is equal to 4. What is given to us? It is given here sec theta is equal to 4. Find the values of the other 5 trigonometry. Total 6 ratios are there, and we need to find out here other 5 ratios. So we draw right angle triangle for theta. We have drawn here. Theta angle is here, one right angle. Now it is given sec theta, and we know the formula. Sec theta is equal to hypotenuse upon adjacent side, means that is base. Okay, so 4 upon nothing was here, so we can write here 1. We can write here 1. Use the Pythagorean theorem to solve for the third side of the triangle. Use the Pythagorean, it means we are using Pythagoras theorem to find out the third side of the triangle. Okay, and one thing more here, it is given in ratio 4 and upon 1. So it is in ratio, so ratio having one coefficient also or not. So we can write here 4x upon x also we can write here, and but when we will solve it at last, so both x will be cancelled. That's why we are coefficient we are leaving here. I'm repeating again, keep the things in your mind. 4 upon 1 is a kind of ratio, and you know very well ratio cannot be written separately without any coefficient. So if we will write 4x upon x separately, we want to write, so hypotenuse is equal to 4x, and perpendicular is equal base is equal to 1x. 1 cannot be right, so 4x and x is there. But when we will find out the value of sin theta, cos theta, tan theta, that will be also ratio, and there x and x will be cancelled. That's why we are leaving here. But if you are writing in that way, that is also right. Okay, so when we will use the Pythagoras theorem, the 4 4 is 16 minus 1, that is root 15. So perpendicular is root 15 coming. Now sin theta is equal to, you know very well, perpendicular upon hypotenuse, so root 15 upon 4. Cos theta is equal to base upon hypotenuse, so that is 1 upon 4. Like that, tan theta, cos theta, sec theta, and cot theta. Sin, and it is cosec theta. Okay, so we can find out these values. And now I hope so you have understood both the examples, but better try to learn in very easy way. If any kind of problem, you can discuss with me. It is a very easy chapter. Okay, so I hope so understood. If any kind of problem, don't worry, you need to ask to me. Okay, thank you everyone, and have a nice day. But homework is there for you, that is exercise 8.1. you need to do that one in homework. If any kind of problem, I will tell you. Okay everyone, thank you and have a nice day.